Hi, and here with us today, I'm here with the Station Flight Control Flight Director, Royce Renfrew. Welcome, Royce. Thank you for joining us today.
You're welcome. Thanks for having me.
Royce, so first of all, you just came off a shift from last week during this particular shift, and I know there were a lot of activities, but first I want to go into just talking a little about you. So just tell me, how long have you been here at NASA?
I've been here about 15 years. I started here as a robotics instructor working with the Increment 2 and Increment 4 crews, so it's a really long time ago.
And Increment, you're talking about the actual missions, the expedition
Correct.
missions. Okay.
Now we're on Expedition 30, so that'll tell you how long I've been doing
It's been a long time.
So I worked as an instructor for a number of years, and then I transferred from there into the robotics operations group, or the robos. So I sat on console a number of missions for robo, and I transferred out of there into the Odin group, which is the group of folks here in the flight control team that are responsible for all the onboard computer system, not the laptops that the crew interfaces with, but the computers that collect data and transmit commands and whatnot back and forth from the ground. I did that for a while. And then I transferred, I was selected as the group lead for that group and worked in that for about a year, and then I was selected as a flight director in May of 2008. So I've been a flight director about 4 years now, done a lot of really cool stuff as a flight director, and I've enjoyed pretty much every day I've been here at NASA. It's a lot of fun to come work out here.
Okay, well, I can't imagine there not being any exciting moments, but tell me, is there any significant moment that was the most exciting for you during your time here as a flight director?
There are a number. When I was robotics flight controller, the day we installed the S0 truss, that was my responsibility, and that was the first truss segment that got installed on board ISS. That's a day that stands out as a very exciting day and a lot of work. The day I was selected as a flight director, it's very competitive to become a flight director, and a lot of folks apply for that job, and a lot of very high quality, well qualified people that are trying to get the job of flight director. And so the day I got selected was a very good day. The 133 mission, I was the lead for SDS 133 on the station side with Brian Lunny was my shuttle counterpart. So the entire 133 mission was very exciting for me, being the last mission of the Space Shuttle Discovery and working with just a really outstanding crew, both from the shuttle and station programs, and there's a lot of big memories from 133. We just actually celebrated our 1-year anniversary of 133 landing a couple weeks ago. So, and then the Increment 29, I was the Increment 29 lead with Mike Fossum and Sergei Volkov and Satoshi Furukawa on the vehicle, and that mission didn't turn out anything like we planned it, but it was still a lot of fun to go work, especially with Mike. I've known him for years, and having him as the commander on the vehicle while I was the lead flight director was really cool.
Well, so you mentioned that mission didn't go any way as we planned it, and as I know that is the case. Explain to us just a little about no matter how much planning we go, how things can definitely not follow that plan, and what is your role in that sort of.
Sure. So really, the flight directors have a bunch of different hats that they wear. Courtney, sitting over there at the flight director's console today, is responsible for today's activities, and she's monitoring all the systems and all the activities that the crew's doing, and is keeping her thumb on the pulse of all the stuff that's going on the ground and what the crew's doing on the vehicle. At the same time, she's planning or reviewing plans that are going to be conducted next day and 3 days out and 7 days out. So the on-console flight director's responsibility is really the down and in, what exactly are we doing today, monitoring the systems, as I said, and always being prepared for when things go wrong, how to triage the timeline, how to work problems that come up, any caution and warning. You always see the caution warning display behind this view in the Ficker here. Whenever that has yellow or red on it, that's somebody in here is doing something because something went wrong on the vehicle. So that's the on-console flight director's job. And then the increment lead flight director, in this case for increment 30, is Scott Stover, and he is responsible for the longer-term plan for this entire increment. So he's not looking at what we're doing today other than hoping that we get it all done today as he planned it. But he's looking 2 and 3 weeks out and 4 weeks out and planning the activities that are going to domino through the cruise timeline and through what we're doing on the ground, and major things like the Epic upgrade or the ATV docking that's coming up, or big major milestones like that. The increment team is responsible for making sure that's all potted and ready to go to hand over to the real-time team to go execute. And then the flight directors also have various different other activities that we'll work on in the office. Like I'm the generic joint operations panel lead, so we look at how we operate the vehicle and what we should change to make that better. There are folks who are leads for various software transitions. We have leads for the COTS vehicles coming up, both the commercial vehicle and the commercial crew vehicle, or the cargo vehicle and the commercial crew vehicle. We have folks in our office who are embedded working on all of those different programs. So we stay very busy even when we're not here on console, doing a lot of stuff to do future execution of what we're going to do here in Picker 1.
Stuff, I like that. Lots of stuff. So talk to me a little about this room, because there's like several, I'm not going to put you on the spot with knowing exactly the number of console positions, unless of course you know that number.
Not off the top of my head.
Okay. Maybe just explain to me a little about how these different folks interact with the flight director, such as yourself, if you're on console.
Sure. So in the room here, we have subject matter experts for everything that's on board the ISS. So next to this PAO console, there's the Thor console, the thermal officers console, and sitting next to them is a console named Spartan, who is responsible for power generation and external thermal. We're actually combining those two consoles, so you rarely ever see a Thor sitting on a console anymore when there's a Spartan on a console. We have folks in here who do attitude determination. We have the robotics officer, like I used to do. They sit in here, but they don't always sit in here when we're not doing something for robotics on board the vehicle. We have the EVA officer. We have environmental control officer. And so just generically, if you want to think of it, there are subject matter experts who sit for everything in this room and who are the point of contact for that system. So Pluto, for example, is responsible for all of the laptops that the crew interfaces with, all the SSCs, and they have World Map running, and they have email, and they have various applications that they run. Pluto is the person in this room who is responsible for knowing everything about that system.
Pluto, not the planet, right?
Not the planet, right. So if there's a problem, if the crew calls down and says, hey, world map's not updating, or hey, this SSC is locked up and I can't transfer pictures to it or whatever, I look to the Pluto console as the subject matter expert to explain to me what the crew needs to do. Have we seen this signature before? Is this something new? So the flight director is kind of at the top of that pinnacle up there, where I have all these people in this room who are working for me, who are subject matter experts in all of the various activities that the crew is doing, and they feed me information. It's my job as flight director to balance all the stuff that I'm getting from all of these people, because sometimes they're in conflict.
It's a lot of information coming in.
One console might want to do one thing, another console might want to do another thing that's going in a different direction. It's the responsibility of the flight director's console to sync all those together and come up with a forward plan that we can all go execute. So a lot of different consoles in the room. There's actually a console in this room sitting in the back corner over there called the ground controller, who is responsible actually for this building. This building is complicated enough that we have a flight control position who has nothing on board the ISS. His or her only responsibility is making sure this building is up and running and that we can command the vehicle and receive telemetry, etc.
Well, it sounds like you have a really big job, and we definitely appreciate all the work that you do for us here.
Thank you.
So we talked about that you were actually there in the hot seat just last week, and there were some activities that were taking place. One of the big activities, I think, was the Robonaut glove testing, and there was a sign language thing. You want to talk to me about that?
Yeah. So Robonaut last week. So Robonaut usually lives folded up and put away in one of the racks on board ISS, and when we're going to do work with him, we bring him out, and he lives in the lab standing on a pedestal right now, because we haven't got the lower portion of the robot up there yet, so we're just working with the torso and the arms and the head. And we've been working with him sequentially since he came up on the 133 mission about a year ago. And then sequentially, we've been working with that particular payload to check it out on orbit. So the very first things that Robonaut did were just move his hands and make sure we could do that, or move his arms and make sure we could do that, or move his head. And we learned a lot about how this robot actually functions in 0G, because it's not the same as he would be functioning on Earth. we've tweaked some parameters and changed some data that we're getting from him. And finally, last week, he actually got to do some really cool stuff. You mentioned the sign language. He signed out "Hello World," which I thought was really cool. We also set him up in the lab and gave him a tool to measure some. It's called a VelociCalc tool, and what it does is the diffusers on board the station are pumping out air that's been filtered, and we always like to measure how fast the air is getting pumped out of those filters. So we have a crew member every now and again go through with this little VelociCalc tool, which has a monitor on one hand and a wand in the other, and hold the little wand in front of the vent there, and then read the numbers that it's transmitting. So there happens to be right near where we usually install Robonaut, one of those outlet vents. So we gave Robonaut the little meter and the wand, and then pretty much just turned him loose. If you were watching the video, you saw that Dan Burbank every now and again came by to check on him, but he was pretty much doing that all by himself. So the ground folks here in Houston and over in Huntsville were commanding him to move that wand around in front of that vent, and then every now and again he'd swivel his head over to read the monitor for us, and actually did some real no-kidding work, which that was way cool. I really enjoyed watching it.
Imagine that. So Robonaut had its first real day of work while you were on post here in the International Space Station Flight Control Room. That had been exciting for you. I know, so you were talking about this particular task, and it sounds like a mundane task, but it's something that has to be done, and with something like Robonaut and its capability, that would maybe free up some crew time?
Yes, absolutely. Anything that we can get the robot to do for us allows us not to the going through and reading the vents with the VelociCalc tool for the crew is actually pretty difficult, because you have to maintain that little wand at a very specific place while you're trying to read this reading at the same time, and for a human that's extremely difficult to do. So oftentimes we'll actually put two crew members to do that. So one's reading the readings and writing the numbers down while the other is holding the wand as steady as they can. For Robonaut's case, once we told him to put the wand in that position, he held it there for 2.5 hours, really just making minor movements to get different readings, which is a real advantage, because instead of me having to have two crew members do that, and there are a lot of vents all over station, so instead of having two crew members go around literally just to read the outputs of these vents, if we could get Robonaut to do that for us, we would not have to use the crew to do that, and then the crew could go do other things like science, like slice, and all the other activities that the crew is capable of doing on board. So anything, the mundane activities that we can get this Robonaut payload to do for us is value added. There's a lot of inventory that we always have the crew do. We have them consolidating inventory from one CTB to another. If we could get the robot to do that for us, that's something anyone can do, but it has to be done, as you said. So if we could get the robot to do that for us and free up that time for the crew to do the stuff that we really want them doing on board, these are great advantages. Sure. I'm going to love seeing this robot fully up and running.
And I suppose potentially one day, we could have a robot actually not only do the mundane activities, but also those activities that may be considered dangerous for a crew member.
Yes, absolutely. So we could one of the ops concepts I've seen for Robonaut eventually is to be able to go do an EVA, which is really cool, to go do a spacewalk, extravehicular activity. To go outside and fix some hardware that we have going outside, or to go outside with a crew member, or to assist in an EVA would be very useful. Being able to send the robot in if heaven forbid we ever had a fire on the vehicle like we had on Mir. If we had that situation and we didn't want to send the crew in there to try to put out this fire or take measurements for us, we could conceivably send this robot in there in dangerous situations that he's well suited for working in, that we conceivably wouldn't want to send the crew in. These are all way down the road, but you saw the first step of that just last week when he actually did some real work on orbit for us and took some VelociCalc readings for us.
Yeah, very good. And so that was very exciting activity that took place last week, but also other activities. I understand the way the timeline works. I mean, everything that we do is kind of a building block for the next thing that we're going to do. So, were there any activities last week that you know of that basically set us up for activities that are going to take place this week?
Sure. So we have this combustions interface rack. I think the I is interface. See it serve. A combustion rack on the vehicle. We do a lot of stuff with fire on the vehicle, as you've seen Don working with Slice today. It has inside it has little bottles of various different kinds of gas that we remotely from the ground, in particular out at Huntsville at POIC where this is operated. They'll take a little droplet of the gas and put it in this little chamber and ignite it, and then they look to see what it looks like when it ignites in 0G. So what we're looking at there is the different properties of the ignition of this gas in 0G with different types of gases. So as we go, we obviously use up the gas that's in this experiment, and then every now and again we have to have the crew go in and take it apart and replace those bottles for us. So Commander Burbank did that for us last week. And I saw on the timeline, I think tomorrow they're going to do some more sure runs with the bottles that he changed out. Some more long-term stuff that we're doing. We're eventually going to get an upgraded communication system for ISS, a high-rate comm system, or HRCS. And that's actually been a very long-term project. In increment 29, we did some work. In increment 28, we did some work. So last week, Dan rotated down a couple of racks for us and installed some additional cabling. And eventually, in a couple of years here, I think later this year, actually, we'll activate that system, which uses the new EPIC cards that we installed in the CNCs, and it'll allow us to get much more data off the vehicle than we do right now, and at a higher rate. So Dan worked on doing some of that. Don's been working with the folks out in Cleveland doing Slice experiments for a while now. Mm-hmm. They did a couple of those runs last week, and it's kind of an iterative process. And it's kind of really like working in a laboratory. At least I think it is. I've never worked in a lab, but I think it has to be. The results of the experiments that Don got last week, the folks in Cleveland who are running this experiment are looking at those results and they're tweaking, what are we going to do? What did we see in the experiment this run, and we're going to go change a couple parameters and look at it in this next run. And they really have a great rhythm going between the folks out in Cleveland and Mr. Pettit there, as far as understanding each other very well. If you listen to the Space to Ground, you'll hear him talking to Cleveland. We don't actually have a NASA center in Cleveland. That's the actual payload developer for this Slice payload who's talking directly to the vehicle. Mm-hmm. And that's pretty neat to watch them interface with each other and really get some quality science out of the runs that we're doing, because we're able to talk back and forth.
Okay, great. Well, I don't think there's ever a week where there's not something big going on, and this week the big event is going to be the automated transfer vehicle, the European cargo ship that will be coming up. It'll be carrying 7 tons of cargo. So we're not going to go into all of that, because we're actually in the next couple of days leading up to that launch on Thursday. We will talk about some of those things, but I want to go ahead and talk to you about any, I believe there was a radiation monitor, and ask if there's any kind of significance of its arrival.
So the ATV, as you said, is going to launch Thursday and it docks this weekend. It's kind of interesting when you think about what we're doing with the ISS in particular. As far as being able to do long-duration missions. So if you look at all the cargo ships that launch, and then you try to figure out if you were going to go do a long-duration mission to an asteroid or a long-duration mission to Mars, how much cargo we would actually have to take with us to be able to do that. You get some understanding of what it's like to do spaceflight, where you can't just run down to the corner store and buy another quart of milk when you run out. One of the things that the ATV number 3 is bringing up is called an IVTPEC, stands for Tissue Equivalent Proportional Counter, which is a radiation monitor. We set it up in the lab. It's bread box size. We set it up in different places in the lab or in the other modules on board ISS. And what its real job is to do is to measure the radiation that it is taking. And it's a tissue equivalent system, which means it essentially essentially mimics a human being, right? So we get real-time data off of this little device, and we can tell if we're getting excess dosage of radiation because of a coronal mass ejection. I know there's been a lot of stuff on NASA TV recently with the coronal mass ejections that we've seen, and some airline traffic that got rerouted and whatnot. So the ISS is flying outside of all of the atmosphere that you and I are in. We're always very cautious and always watching what the radiation environment looks like on board ISS. So this little device that's coming up to replace a different TPEC that's already on board that's run out of life, we'll replace that, and we'll be able to monitor in real time what kind of radiation the crew is being exposed to with these new coronal mass ejections. And we've been doing this for 10 years. The sun has gone through a couple of cycles now, so we have a really good handle on it. The ISS itself is shielded specifically for radiation. There are specific places on board the ISS that are more shielded than others, like the crew quarters that the crew sleeps in are shielded more. So, and we've never, as far as I remember, and I've been doing this for a long time, I don't think we've ever asked the crew to go to a specific place on ISS, but it's just like everything else. We monitor that at all times just to make sure the crew is safe and happy and healthy, and just like we're monitoring the air that they're breathing to make sure the ppCO2 is not getting too high, or the temperature or humidity. This is just another item that we monitor here from Houston and from various other control centers around the world to make sure the crew is in a good config.
Great. So, again, just borrowing a word from you, lots of stuff going on aboard the International Space Station. So now I'm going to put you on the spot. And
okay.
It's not me, it's actually the public. We polled the public for a couple of their questions, and we have a couple here that came to us on Twitter. The first one comes from Arthur Hartman. He asked, what is the duration of a mission?
So the crew usually spends 6 months on orbit. So they launch, and then that 6 month on orbit is usually divided up into 2 month increments and 4 month, or 2 month pieces and 4 month pieces, the way the crews rotate out. So they launch on a Soyuz. For example, Commander Burbank launched, and his undock date is the end of April 30th, and that'll be right at 5.5, 6 months for him. He actually launched a little bit late, and then he's going to undock a little bit late because of some problems that we've been having with some Russian rockets. But generically, it's a 6 month increment for a given crew, but they'll usually launch and then spend 2 months with 3 folks, and then those 3 folks will undock. Another 3 folks will come up, and then they'll spend 4 months with a different set of folks, and then they'll undock. So it's a 6 month overall increment. The flight directors, for example, divide that up into 2 different shifts. So I had increment 29, which was the 2 month piece, and then Mr. Stover has increment 30, which is the 4 month piece of this increment.
Okay, great, thank you. We have another question. The second question from that we have from Twitter comes from Frazzled Jazz. He asked, do you think it would be better with or without gravity up there?
I think sometimes I wish we had gravity. One of the things the crews always try to hammer home for us is whenever we develop a procedure that they're going to go execute, we always have gravity there to help us. So we've got a bag, and in that bag it's got 15 pieces that we need to do this activity. We can go take that bag and set all 15 of those pieces out on a table, and they're all nice and pretty, and we can start in the top row and work our way down. When you try to do that in space, as soon as you open that bag, unless they're all tied down, you get 15 pieces of hardware floating everywhere, and you're trying to go keep track of all of those. So having gravity to help you on the is actually a nice thing, and sometimes I think it would be advantageous if we had gravity on the vehicle. But in reality, the reason we have the vehicle is because there isn't any gravity. The slice experiment that Don's working with here, what we're really looking at is something that's as fundamental to human nature as fire, right? Fire that we all know and love and use for warmth and illumination and to drive our cars and whatnot. It's absolutely, everybody, you can talk to anybody and ask them what fire is and they can explain it to you. What we're doing with fire on board ISS, though, is taking that one critical piece out of the equation, that is gravity, and seeing how fire responds in a zero gravity environment. And it's conceivable, hopefully, that what we'll be able to do then is understand fire that we've all known for hundreds of, thousands of years, and learn something new about it and how it actually behaves and how we can change how it behaves on Earth, because we're taking that one variable out of the equation, which is gravity. A lot of the stuff that we do on board ISS, it counts on the fact that we don't have gravity in the environment. There are a number of metallurgical studies that we've done where you heat a special piece of metal up and different alloys in it, and then you cool it down really fast and look at the crystal growth, the crystalline structure of the metal as it cools down. When you do that on Earth, the gravity will pull on the molten metal and force it to form specific crystalline structures. When you do that in a zero-G environment like on board the ISS, you can actually see the crystalline structures that are trying to grow and are conceivably better than what we can do in a 1G environment. And so someday there may be factories in space that are producing super high quality steels, because we can take advantage of the fact that gravity is not trying to force the crystalline structures into a particular lattice as it cools down. So to answer the question, sometimes yes, I think it would be good if we had gravity, but that would really defeat the purpose of ISS and our ability to study all kinds of interesting things without gravity, or removing the variable of gravity from that equation.
Great, thank you. So it sounds like gravity is helpful for logistics, but there are definitely some advantages of having that microgravity environment, which is one of the reasons we're up there. Thanks again for joining us today.
Sure.
I think that's about all the time we have, and I really do appreciate you coming over and talking with us, and we'll get back to the space station and listen in and find out what's going on aboard the International Space Station today. Thank you.